Hi, everyone. My name is Amelia Richardson. I am a senior from Albuquerque, New Mexico, and I'm studying civil engineering with a focus in environmental engineering. Today, I'm going to be talking to you about my civil engineering capstone project that I did in our concrete class this past year. So just to start off with, so I'm here at KU your senior year. So throughout your first couple of years as a student, you're really going to be building up your knowledge, your foundation for kind of getting into these design courses that you'll take your senior year. So the great thing about civil is that you actually have a lot of different options for what senior classes you want to take. And one of them is CE 563, Design of Reinforced Concrete. So as part of this class, it kind of revolved around three main topics, one of which was just doing general classwork. And the classwork was done in accordance with the actual concrete code that all construction people use, all designers use, just part of our standard for doing concrete design. So we did a lot of classwork focused around that. We also did labs. And so a lot of times the labs weren't actually us doing any labs. It was more working on problems, using that concrete book to kind of actually do real world problems of how we would design structures and beams and such. But the last big part of it was doing this group capstone project. And so in this, we actually completely designed and built a reinforced concrete beam as part of this. So that's what I'll be talking about today. All right, so our beam, so he gave us standard dimensions, our teacher did. So our beam was a 6 by 8 by 72-inch beam, which is pretty big, almost as tall as I am. I'm like 6 feet tall. So it's a really nice size beam. Now, the cool thing was that each beam got to have a different strength of concrete. So the one that our group did was a 10 KSI, which eventually you will learn this, but it is a high strength concrete. So ours was supposed to be super strong, able to hold up to everything, but as well as having high strength concrete itself, we also had two number 3 bars, steel bars on the top, and two number 5 steel bars on the bottom, as well as number 3 stirrups across the beam. So our beam in summation was very strong and was supposed to be able to hold a lot of load and withstand a lot of shear, a lot of things like that. All right. So how did we go about actually designing and creating this beam with those kind of general dimensions and standards given? So for those of you who don't know, so when you're talking about concrete, it's made up of 4 main materials, and this is cement, water, coarse, and fine aggregate. Now, we use a lot of local products for our concrete beams. So we use a typical, what we call a 28-day cement, but we also use for our coarse and fine aggregate, we use crushed limestone and Kansas River sand, which are all local here from Lawrence. And we used a water reducing admixture. This was because our concrete was so high strength that we really didn't want to add a lot of water to it. So besides having the water, we used that reducing admixture to kind of give it that extra little strength, a little kick in it. And then the reason we chose that 28-day cement was that that was how long it took from when we initially made our mix to when it was finally set and not wet anymore. So that was kind of the mix that we used because we had 28 days. That was our typical cement use. So then we had to create enough concrete, not only for that 6 by 7 by 72-inch beam, but also for us to do test cylinders. So throughout that 28-day period, we did a test every 7 days. And so we needed enough cylinders to also see how strong our concrete was getting. So that little image at the bottom was part of a very lengthy calculation set that we did to kind of figure out how much cement, water, coarse, and fine aggregate we needed. And as you can see, there is a whole lot of weight down there. We use 175 pounds of cement, 54 pounds of water, 332 pounds of coarse aggregate, and 149 pounds of fine aggregate. So we had a lot of buckets, a lot of fun making this. I definitely got a little workout for the day from doing this. So here are just some awesome pictures from when we actually created this foam work and when we created our concrete. So on the left, we actually went through and got all the wood planks that we needed to make the form for it. And then in that picture to the left, on the right side, you can also see our steel cage that we made. So the steel was provided, but we actually did construct the form work and doing the steel cage for it. So that was kind of the first step that I've talked about. The middle 2 pictures are when we actually were going through the process of making the concrete itself. So the one on the bottom is a giant drum mixer. So step by step, we added in some coarse aggregate, some fine aggregate, a little bit of cement and some water, mixed it all together, and then continually added in more of it until all of those pounds that we initially calculated were inside of it. And then the last picture on the right is when we took everything from the mixer and then added it into that form that had the steel cage in it. So you can see that we're in there, we're adding all of it in like giant little shovels, and we were wheeling it over in a wheelbarrow. It was a lot of fun. And then also what we've put inside of that form is a vibrator. We use that because we want to make sure that when we're adding all of it, at first kind of, when if you're ever like mixing stuff together, you do have air bubbles that form. So that was our way of consolidating it to make sure that there were no air bubbles, because those would have led to a lower strength concrete design. And so we use that to make sure that all the water, all the aggregate, all the cement, all that was mixing together, and that there weren't a lot of air bubbles inside of it. Okay, so like I mentioned, so we had 28 days from when we initially made it to when it was going to be final. And so each 7 days, each week, we went in and we tested those cylinders that we created. So on the left, you can see a result from one of the tests that we did. A really cool thing that we found out is that after 7 days, I believe that after 7 days, our first test showed that we had already hit 7 KSI strength. So really, we were hitting a pretty near range of where we're supposed to hit pretty quickly after we made it. But here on the right, I do have a little clip, and let's see if it'll play, of the concrete testing. Let's see. Right. So super explosive. That was also a really cool thing about our high strength concrete, is that because it was so high strength, it wasn't just going to be a nice little like where you could see the cracks, see it start to crumble. It's very explosive the higher strength you go. So it was really a lot of fun getting to do this. It was my first time working with concrete. It was our first time working with it and getting to do this stuff. So it was very cool. All right, so did all that testing each week. Eventually we did hit our testing day. So on this day, we did take off the wood panels so that way we could get to the concrete beam itself. And we could see we were group on the top of Sharpie. So we put it into this awesome testing apparatus. So we put it on there. We applied the load on the top, but we did have supports on the ends underneath it. So we put our giant beam there, but we also did a final test on our final cylinder, and we call this a split cylinder test. All the other tests that you saw the pictures of beforehand, we call them compression tests because you're applying load on the top and bottom. This one we did call a tension test, a tensile split test, because you're doing it on the side of it. So it kind of split it right in half, as you can see, while the other ones kind of had that explosive reaction to it. So we did that just to see what the tensile capacity of it was, because concrete is very strong when you apply top and bottom pressure, but when you do that side like that, not as strong. But we just kind of want to get a bunch of different variables kind of into about how strong it got. So this was some of the pictures from the results of the testing that we did. So as load was applied, you could see the cracks forming on it. We had a bunch of different failures occur. So for one, I know I mentioned tension failure, and this is what you want. So if you imagine that you have this beam inside of a room, inside of a building, you want to see those cracks forming underneath first. And that's a good sign. It shows that it's failing exactly where it needs to. You can see those cracks. Your beam will still hold, but it is showing cracks in the concrete itself, but your steel is still holding on to it. But eventually, after we did add enough load on the bottom, you can see it did fail in compression, which means that it started crushing on the top. This is a little bit worse of a circumstance because that's when your concrete is actually starting to break off, starting to crush up there. Your steel on top is not as strong as your steel on bottom. So this is a pretty worrying sign. But we only did this because we hit the desired failure that we wanted, but wanted to see ultimately how much strength it could take if we kept applying load. So eventually we did hit that failure. But then over on the right, you can see that I also mentioned shear failure. So with this, besides having the concrete, having those rows of steel on top and bottom, earlier, as you saw in the cage, we also have steel that kind of was put every other 6 inches across the beam. And this was to prevent shear failure, so it hitting kind of sideways. And this awesome one that you can see is from that shear failure. And so we ultimately did get that as well. So reflecting back on this, it was so cool because we already had great testing. We had a great time making this. And then everything that we had been learning in class. So learning about kind of what leads to tension, what leads to compression and shear failures, how we calculated those. It was really cool because you were hearing about how to calculate them, but we hadn't really seen it in person yet. So getting able to do this and getting to see all 3 of them, it just really kind of emphasize what we had already been learning and kind of put in a real example of like when these are applicable and kind of what they look like and such. So that was very cool. Yeah, so kind of wrapping it up. So in conclusion, after we tested it, in the top right corner, you can see a picture of what the beam looked like afterwards. As you can see, not so straight anymore. It got very bent. That middle side definitely took a hit. So it was really cool getting to see that. On the bottom, I also included a picture just from one of our last tests. Like I've already talked about, it was super high strength. So all of the rocks, all of the aggregate we had in it, it was actually so high strength and so well mixed that the rocks themselves split in half. So it wasn't like it broke apart and it like went around the sides of the rock. We actually like split all of those rocks in half as well. So it was really cool getting to see that. Our teacher was very impressed. So it was really awesome. But after all that, we wrote a final report just kind of talking about how we made it, the calculations we did, everything like that. And that was what we turned into our teacher. And then this genuinely, like throughout my time in engineering, this is probably one of the, like the coolest things I've ever done. The teacher for that class, there's two different teachers and both of them are just absolutely phenomenal. They're great professors. And this project was just so much fun because like everything we were learning, it was so easy to follow through with it. And like it was challenging at times, but I never felt like at any moment of it, I was not prepared. Like I didn't know what I was doing. It was kind of this first experience where I was like, oh my gosh, like I'm actually leading the charge in this. Everything I'm learning is getting applied in this. And it really just kind of emphasized what we were learning in the classroom itself. So yeah, so this is my project and it was great talking to you.